In today's class, we will see what is data acquisition in IC engines. Okay, so this comes under Unit 5 in the subject Advanced IC engines. It is a small topic. So, what is data acquisition in IC engines? So, before that, we have to know generally what is data acquisition. Data is nothing but any information. It is called as data. Information is called as data. Okay, so acquisition is getting data. So we will go to the first slide. So what is data acquisition? So this data acquisition means it is used to measure some parameters. It is used to measure some parameters. Why we measure? We have to measure because to improve the accuracy. So we have to know what is the purpose, and we have to know what do you mean by data acquisition system. So data acquisition means it is used to measure something. Why it is measured? It is used to measure because to improve the accuracy. So this data acquisition has two major parts. One is the hardware components, next is the software components. So this data acquisition is basically an electronic system, and it contains both hardware and software. So in case of hardware, you have certain things. First is sensor, next is signal conditioning, third is computer, fourth is data acquisition card. So see my cursor, it moves. So this hardware part is made up of sensor, signal conditioner, data acquisition card, and computer. So these are the major parts which plays a vital role in data acquisition. Okay, now we have seen what is data acquisition and why data acquisition is used, and what are the major parts of data acquisition. So hardware and software, and what is inside this hardware, namely sensor, signal conditioning, data acquisition card, and computer. So this is about data acquisition. Now we have to know, using this data acquisition, what we have to measure in IC engine. So this we will be seeing in this slide. So you can see the topic, what we measure in IC engines using data acquisition. So there are certain points here. See, in an engine you will have a spark. So you should measure the spark current, then you can use this data acquisition. So in an engine you have an injector, in an injector you have a needle. So how far this needle is lifted, so you can use this data acquisition. So you, for spark current measurement, for injector needle lift, you can use this data acquisition. So for example, you have to measure the fuel pressure, you can use data acquisition. Suppose for example you have to measure the angular velocity, then you can use data acquisition. For example, you have to measure cylinder pressure data, then you can use data acquisition. So there are certain things, certain points mentioned here, namely 7 points. So for measuring the 7 points, we can use this data acquisition. Can you understand? So you, for measuring this 7 points, we can use this data acquisition. So you have to know, before entering to the components of data acquisition, we have to know what is data. Data is something, an information. So what do you mean by data acquisition? It is used to measure some parameters. So this data acquisition is divided into two things, hardware and software. Hardware is made up of the sensor, signal conditioning, data acquisition card, computer. So these are the major hardware. So we have to know. So what we have mentioned in red, sketched things. These are the major hardware parts using which you can measure. So all this data acquisition is done because to improve the accuracy. So major point in using all this thing is it is used to improve the accuracy. So this is the major highlight. Okay. Next we will go to the diagram here. You can see this diagram. You can see this engine. You can see a cylinder. You can see a piston. Everything. Okay. You can see a spark plug. So in this engine, you can see there are so many sensors placed here. So namely 1, 2, 3, 4, 5, 6, 7, 8. Then AB. So and this name of the sensor is given here. Given here. For example, I will say you this one is throttle position sensor. This two is airflow sensor. This three is fuel pressure sensor. Fourth is crankshaft speed sensor. 5 knock sensor. This is temperature sensor. And 7 and 8 are both same oxygen sensor. Okay. Now what about A? Fuel injector. What about B? Ignition coil. So it is also the sensor. So there are major types of sensor located in engine, and each and every sensor plays a vital role in giving signals about something. Okay, you have to know what is throttle position sensor, what is airflow sensor. So we have to know all the sensor functions. Okay, why we are going in detail view about the sensor is in data acquisition. Sensor is major important thing. It is an hardware part in data acquisition. So we have to know about sensor also. So we have to know about sensor also. So without sensor, the advancement in IC engines is difficult. So we have to know the functions of sensor. For the functions, I have given in a separate slide. For example, these are 12 sensors. If I go to MAF sensor, what is the function of MAF sensor? It notifies, it detect the mass of air. Suppose for example knock sensor, it says knocking ratio. For example crank position sensor, it monitors piston position, top dead center position. For example, if I want to know the engine speed, we have to go for engine speed sensor. If you want to go know the fuel pressure, we have to know the fuel pressure sensor. So likewise, there are said to be 12 sensor. Each and every sensor, it detects something, it monitors something, or it regulates something. So we have to know the major functions of various sensor. So sensor plays a vital role in data acquisition. Okay. So all this data acquisition, everything is used to improve only the accuracy. So what is the purpose of implementing so many sensors or implementing data acquisition system DAC? So everything ultimate purpose is to improve the accuracy. Okay, so we will go to the components of data acquisition. So here you can see the components. There are said to be 6 components: ADC resolution, second is triggering, third is external clock, fourth is pressure transducer, fifth is charge amplifier, sixth is heat release analysis in engine. So these are the various components. We will see one by one. Okay. First we will see what is ADC. So ADC, it is A for analog, D for digital, C for converter. It is analog to digital converter. Okay. So what is the purpose of ADC resolution? So if there is any pressure change, that can be recorded using this ADC resolution. So in data acquisition, if you want to measure the pressure change, you can use the first component, which is nothing but ADC resolution. Okay, so you have a separate formula del P by del P small p, which gives you del capital P divided by 2 power of R. Okay, so whereas this del capital P is total pressure, R is resolution. Okay, so we have to go for ADC resolution if you want to measure pressure change. Okay, this is about the first thing. Now what about triggering? So we will go to triggering. For example, I have to record the cylinder pressure data. Okay, I want to record cylinder pressure data and I have to align to cylinder volume data. Then I use this triggering. Okay, this triggering accusation is achieved if I want to record the cylinder pressure data. So I have given in 2 points. You can read this point. The requirements of combustion data acquisition system are to record cylinder pressure data, and it has to be aligned with cylinder volume data. This can be achieved only by triggering acquisition. Okay, so what is the purpose of triggering? If you want to record cylinder pressure data, you can use triggering. So first is ADC resolution. If you want to record the pressure change, if you want to record the pressure change, that minimum change can be recorded using ADC resolution. If you want to record the cylinder pressure data, then you have to use triggering. Okay, so these are the first two things: ADC resolution, triggering. So now we have seen the two components, ADC resolution and triggering. We will go to external clock. In case of an engine, you know a piston moves from BDC to TDC, TDC to BDC, top dead center, bottom dead center. So piston moves and there will be a rotational velocity in engine. Okay, I will again repeat. In any engine, the piston moves from TDC to BDC and BDC to TDC, and there will be a something called as rotational velocity because the engine moves, and this rotational velocity is changing from time to time. So it changes in one second, it changes, and in another second it changes to some other value. Okay, so you cannot measure using the clock frequency. Okay, you cannot measure. If you want to measure this rotational velocity, you cannot measure using the clock frequency. So what we have to do is we need a external clock. External is something, a clock which is attached from outside. So this external clock we need so that it purpose is only to measure the rotational velocity. Okay, so external clock, what is the purpose? I again repeat. So there is a velocity, rotational velocity in an engine, and it changes from time to time. Okay, so it changes from time to time, so you need a external clock to measure it. So that is called as external clock. So three components: ADC resolution, triggering, external clock. Now we go to pressure transducer. Here the pressure transducer, general pressure transducer, we use piezoelectric pressure transducer. Okay, it is one commonly used, and the pressure transducer, it is used to acquire the pressure data. So it is a simple one. So if you want to know the pressure data in cylinder, then you use this pressure transducer. What is the pressure transducer used here is piezoelectric. So we go for components. In we components of ADC, we have the ADC resolution. Again I will say you triggering, external clock, pressure transducer. At last we go for heat release analysis. So what is heat release analysis? It is somewhat important. Okay, and it is a critical one too. It is a critical parameter too. So in the second point, you please read out the heat release rate HRR is a critical parameter to characterize a fire. Okay, so this is important point. Suppose I want to measure the heat release. Okay, if I want to measure the heat release in an engine, then how do I calculate? That is the question. So I will use the crank angle to calculate. I will use the crank angle to calculate. So there may be different methods, but widespread method is based on the mass balance. You measure the mass loss, then you can arrive at heat release. If you measure the mass loss, then you can arrive at heat release. Okay, so if you go to heat release analysis, if you want to measure the heat release, then you measure the mass loss. It gives you the value of heat release. There is a graph also, separate graph. You can study it, and you can analysis it. So I again repeat. So what is data acquisition? Data acquisition is something which is used to measure the parameters. It has two components, hardware and software. Hardware, you have sensor, signal conditioning, data acquisition card, computer. And what we measure using this data acquisition, you can measure the spark current, fuel pressure, angular velocity. And we have to know what are the sensors in an IC engines and what is the purpose of this sensor. Then we will go to the components. Components, we have namely 6 components. First is ADC resolution. I have said if you want to measure the minimum amount of pressure change, you use ADC resolution. In case of triggering, if you want to record the cylinder pressure data, you use triggering. If you want to measure the rotational velocity of an engine, you use external clock. If you want to measure the pressure, you use pressure transducer. Here piezoelectric is used. If you want to measure the heat release, then you can use the mass loss. Using this mass loss measure, you can calculate heat release. Okay, this is about data acquisition in IC engines. So we have an assignment. So what all I teach to you, explain the data acquisition and components of combustion data acquisition. This you can write and submit.